So with this, we have a clear-cut understanding uh, about simple linear regression, specifically the theoretical understanding about simple linear regression. So now it's time to get into one example. So, but before we start working on example for the simple linear regression, uh, I'm going to explain the key steps in the supervised machine learning process. So we will look into the each and every step that we are going to take up to make a strong machine learning model, specifically supervised machine learning model, and our simple linear regression comes under that. So let's look from a macroscopic view to the microscopic view. So now let's look into the macroscopic view and slowly let's get into the microscopic view. So if you see from top, like bird's eye view, the overall picture. So let's put a supervised machine learning process into three steps, just three steps. So first we will understand supervised machine learning process in three steps. Then we will get in details of it. So the first step under supervised machine learning is data acquisition. Okay. So here, obtaining and loading the dataset, checking the dataset's structure and format, then verifying the data integrity and addressing any issues with data loading. That's what fundamentally we do with the data acquisition. At the end of the data acquisition, you will have a solid data set. It could be a .csv format or something else. Okay. So once data acquisition is ready, your data set will be ready. Now let's move on to the second step. So second step, I call it as a pre-processing step. Pre-processing step, it's very a time consuming step. So most of the time, maybe 90% of time for a project, the data scientists would spend their 90% of time and efforts in pre-processing step more than working on the model. So the most important step is pre-processing. So now what all things we're going to do in pre-processing? So in pre-processing, so we will be handling missing values, imputing missing values, removing instances of features with missing data. That's data cleaning. And in addition to that, we will be handling the outliers, detecting and addressing outliers through techniques such as trimming or winsorization. Then we will be getting into the exploratory data analysis. In exploratory data analysis, we will be working on, we'll be looking into the data. We will be trying to find out the patterns of data. So here we will use statistics, basically summary statistics, examples, quartiles, percentiles, such as descriptive statistic tools, and mean, median, mode, standard deviation, and data visualization, such as create histograms, bar charts, line plots, scatter plots, box plots, and heat maps to visualize the distribution and relationships between variables. We can use pie charts, donut charts, or stacked bar charts to analyze categorical variables. Then in exploratory data analysis, we also do some correlation analysis, calculate correlation coefficients such as Pearson correlation to determine the strength and direction of linear relationship between the variables, and we can use scatter plots to visualize the same. Then we also do data profiling, so explore the data structures, including column names, data types, missing values, and unique values. So once that is done, exploratory data analysis, we'll be getting into the feature engineering, FE, the feature engineering. So feature engineering, if you look into this, if you want to understand what is a feature engineering, first you have to understand what is engineering. So engineering is anything which will be modeled first, then designed, then built. So that's called engineering. That could be a mechanical system, or it could be a electrical system, electronic system, computer system. So engineering is basically that's what. So from this building, modeling, designing, and building. Similarly, here also we will model, design, and build a features out of variables. What you have in your data set, what you will have in your data set is a variables. So those variables will be made, will be converted as, will be engineered. The variables will be engineered as features. That's why we call it as a feature engineering. So here in feature engineering, mainly we will do two tasks. One is either feature selection or feature extraction. For that, we'll be using such as dimensionality reduction techniques we can use here, and principal component analysis, or TSNE, to reduce the dimensionalities, and just to find out the patterns, like we can use algorithms of k-means and that sort. So anyway, feature engineering is specifically talks about feature selection and feature extraction, and the techniques and tools that we have to use in feature engineering, we are going to discuss in our forthcoming slides. So then we have data splitting. So data splitting is nothing but splitting your data set into two parts. One part is training the model, or training the algorithm to make a model, and second one is to test the trained model, or test the build model. So this is what we call as a data splitting. So once with this data splitting step, we are done with pre-processing step. Now it's time to get into the most important step, that is model building and evaluation. So now we'll be getting into the model building and evaluation. So in model building, so the most important aspect is choosing an appropriate machine learning algorithm or model based on the problem and the data characteristics. That's the most important step. So that is the reason the most of the data scientists who works on machine learning projects, when I say, I specifically wants to convey that these these models or algorithms are not of neural networks, excluding the neural network algorithms. Whenever I say machine learning algorithms, you should understand and consider as the algorithms excluding neural networks, excluding deep learning. So you have to see a machine learning algorithms with a separate prism, and deep learning algorithms with a separate prism, because you can't fit a common tool into the two separate machines. Okay, this is separate machine learning and deep learning, because the way they function, the whole ecosystem is separate. So that's the reason. Now I'm only worried about machine learning algorithms, not deep learning. So whatever I speak, whatever I present with respect to the machine learning, when I start deep learning, that's a different issue. Okay, so now machine learning. So the most of the data scientists spend most of their time in understanding the data, in understanding the data characteristics, so that they can choose a better and appropriate machine learning algorithm. From that algorithm, we can build a model. Okay, so first, model selection and configuration. Once that is done, once you have decided with an algorithm, now it's time to call a class object, or we can say that it's time to instantiate a class object. Example, so we have sklearn, scikit-learn, sklearn. From that sklearn library, we are gonna call up linear models package. From that package, we are gonna import linear regression module. From that module, we are going to use a linear regression class. With that class, we are going to instantiate object. So that's what the next important step. So here, from library, package, module, from the module, we will be instantiating the class object. The most important aspect, if you want to understand the steps that you do while working on model, you need to understand OOPS, object oriented programming first. Then working with model actually is a cakewalk. I'm specifically talking about the third step, that is model building and evaluation. So that's a cakewalk, because at the end of the day, what we are doing is object oriented programming. We are using object oriented programming. So oops, so we will be instantiating the class object of the linear regression class, and we will be applying the methods of that object to proceed further. So once our model object has been instantiated, now let's get into the next step. This is model training. In model training or algorithm training, what we are going to do, we are going to use fit method of the instantiated class object. In this case, our class is a linear regression. So from that class object, we will say that class object dot fit, and we will put the data into that x comma y. So then algorithm will be trained with the data, then the algorithm will be transformed into a model. So once a model training is done, now it's time to test the model. So how do we test it? Then again, we have to use the method. You have to use the method of the instantiated class object. Which method we are going to use? Predict method. So here object dot predict, and we have to give only x values. That's x test. So then we'll get the y test, y predicted values. Okay, y predicted values. Now you will have a y predict and y test. So these two values we'll use to evaluate the model. Okay, normally for the simple linear regression or regression models, we'll be using mean square error or RMSE or MAE, that's a mean absolute error, or it could be R square score. Okay, so once the model evaluation is done, now the final step is model optimization. So model optimization step is nothing but we will use depends upon the algorithm. We'll use a fine tuning. We'll do the fine tuning to that model, or we'll use some other techniques. So bagging or some other techniques to improve the model's performance. That's called a model's optimization. So this is the macroscopic view of supervised machine learning process. Fundamentally, it's a 3 steps process. It's a step by step process, but it's not a straight line process. You have to repeat some steps again and again. It's like, again, iterative process. So we'll begin with data acquisition, then we'll go for the pre-processing, then finally we will do the model building and evaluation. So now let's look into the microscopic view. Now let's fall from macro to micro. So the first step, if you look into the microscopic view, that's a data loading. That's the first step we'll do. Once data has been loaded, then we will do the data cleaning, then exploratory data analysis, then feature engineering, then data splitting, then model instantiating the class object, or we can call it as a model object creation, then model training, then model testing, then model evaluation, and the final step is model optimization, and final one is model optimization. Okay,